Chapter 2, Section 6, Algebraic Proofs, possibly the last video for 2020. The algebraic proof, geometry, a big geometry concept is proving that things are true, and it's called making a proof or doing a proof. The logic that we've been learning in this chapter will help you become successful with that. And here's a little PowerPoint talking about it. Okay, so I have this here. This is in the book. These are properties of real numbers, and it looks overwhelming, like there's so many of them. But to be honest, these are the ones that we're going to use because we're going to start off by doing with proofs by doing algebra. It's called an algebraic proof because I think that you know how to solve equations. I think you know. I think you know too, hopefully. So you would be confident in that situation. I give you an equation, I say solve it. But that's not going to be the assignment. It's going to be to solve it, but you also need to make it into a proof by justifying each step. And maybe you didn't know this, but when you add something to both sides of an equation, it's actually called the addition property of equality. So if you have a left, if A equals B, in other words, if you have the left side of your equation equal to the right side, A equals B. And then if you add something to both sides, it says add C on the left and add C on the right. It doesn't change the meaning of the equation, and it's a strategy that you use to solve equations. I have some examples. And so sometimes you add, subtract, multiply, or divide to both sides. That's why it's called of equality. You do it to both sides of the equation, and it doesn't change the meaning of the equation. It helps you solve it. And the other thing is a distributive property, and that has to do with taking the number on the outside and multiplying it to the two numbers on the inside, and then either adding or subtracting the answers you get depending on the answer's sign, if it's positive or negative. So this is how the book lists it, and now when I go back and look at it, it's not as overwhelming maybe. Addition, subtraction, multiplication, division, property of equality, same thing I just showed you. The reflexive property is when you say that something equals itself. I'm not going to go over the rest of these though, well, distributive property, because that's something that you will do when you start doing geometric proofs, and we kind of don't need that yet. Okay, so that's why I put this in here. I got this from Alex, and I'm not testing you on chapter 2 as such, like alone, but there are a few questions that I put on the final exam that are from chapter 2, and this is the chart that they use to explain how to do some of them, and some of them are just like the ones for today. So notice how if it said, if it just said, hang on, let me move this little guy out of the way. If it just says solve this equation, I think you could do it. I mean, this is kind of a long left side, so there's lots of places where you could make a mistake. But you would still, you've been taught how to do that. Like when you look at that, you're probably thinking, oh, I'm going to distribute the 2 here. I'm going to distribute the -4 here. And that's a really great way to make mistakes. I mean, that's correct, but doing it correctly is another thing. And then you're going to end up combining like terms, putting something on the other side. Okay, so here is how it's different now. The first thing you do, okay, so it says also write a justification for each step. So since this is baby steps for proofs, when you go to prove something, they give you something that you're to accept as true, and then they say prove something else based on what they give you. Okay, so what they're giving you is the original equation, and you're going to solve it. You're going to prove what the answer is. Okay, so the very first, there's algebraic steps, and there's going to be properties that are going to write a justification for each step. It's going to be a property. So why do I know that why do I have this equation? Well, because it's the original equation. And honestly, I would probably write, instead of that, I would just write given, because I was given that. Okay. Okay, so anywho, that a little bit. So you could write the word given to just practice, like this is going to be like an actual proof. Why can I say that this is true? Because it's given. Okay, now what would I do first? I would use the distributive property. So you actually multiply those little guys out. And 2 times 5 is 10, 2 times -3, -6. This -4 came from taking -4 times A. -4 times +7 is -28, so they put a -28 there. Why did they do that? Because of the distributive property. So these are the steps, and these are the properties. Now, the next thing most people would do Well, it depends on the person, right? But algebra teachers show you like, hey, simplify the left side first before you do any algebra. So this step is the simplifying step. And in the book, it calls it the substitution property because technically it is, but it's okay to call it simplifying. So what did they do? How did they get from here? Where did this negative 18 come from? It came from 10, and then the other like term is a negative 28. 10 minus 28, negative 18. Okay, where did this negative 10a come from? Negative 6 minus 4a could also be written as negative 10a. That's why they call it substitution property. But in algebra, we call it simplifying, okay? And then now you can start doing algebra. And normally people, whoops, okay. Normally people would be like, okay, I'm gonna add this 18, since there's a 92 on the right side and there's a negative 18 on the left side, what you can do is you can add 18 to both sides to solve it. Most people write it underneath, seriously, right? And maybe they don't write as pretty as me. The book writes it on the same line. I have my PowerPoint messed up, so I'm giving you 2 lines ahead of time. Sorry, spoiler. Okay, so you know how I wrote plus 18 underneath? Look, they put it beside, and honestly, that's just because when books are published, it's easier to have it all in one line. It's like one less line that they have to print, okay? So that's why it looks like that. But what they did was they added 18 to both sides, and they showed that step, and they wrote addition property here, okay? If you do that part in your head, then you would just write, then maybe you wouldn't write this step at all, and you would just write, okay, I'm gonna add 18 here, so I have negative 10a, and then 92 plus 18 is 110. So maybe you would just go straight to this step, and so you would only have the reason here, addition property. But since they showed their step, they have to also write, I would write simplify, but they wrote substitution property, just so you get used to the fact that it's the same thing. Now, how do you solve this? Well, you would divide both sides by negative 10. So they showed that, and they called it the division property. And since they showed it, they need to do one more step before they can simplify, and they actually divided. Okay? Now, this is actually called a 2-column proof. The next thing I'm going to show you is that it actually comes right out and says it. Write a 2-column proof. The reason it's called a 2-column proof is because, check this out. Well, what if I do this one first? Undo. Look, we have 2 columns here. We have all the steps on one side, and we have the properties on the other. And what they usually do is they usually draw a line at the top, because this is like the title of each column. And it ends up looking like a T-chart that you've used in Algebra 1. It's not. It's called a 2-column proof, okay? And you didn't even realize where you were doing it. And all this time, whenever you read examples in the book, they always say the reasons on the side. Those are justifications for each step, because they're trying to teach you how to do the problem. So they're showing you this is why you can do it. And now you're gonna learn how to do proofs. So this is how you can practice with something hopefully you already know. Like, you know how to solve an equation. Maybe you're not good at showing steps. And in geometry, I don't make you except for this one section, right? Because you have to practice showing them for this section. Whoops. Alrighty, and then go to the next example. Science. Okay, so what they're going to do here, it says if the distance d of an object traveled, if the distance an object travels is given by this equation, the time t that the object travels is given by t equals d minus 5 over 20. Write a 2-column proof to verify this conjecture. Okay, what are they giving me? And that's even what it says here. Begin by stating what is given and what are you trying to prove. Okay, they gave me this original equation right here. So that is given. And we're trying to prove that you could rewrite this equation like this, and it would give you the same, it would be the same, an equivalent equation, basically. Okay, you don't do a lot of this in Algebra 1. It's very useful in science class. The science teachers are like, why don't you teach them that? We're like, well, we kind of do. Remember, you're given this, so that's going to be your first statement. Oh, I forgot to say that on the last one. These were called algebraic steps, but if it was a 2-column proof, these would be your statements, all the statements that you're saying, and these would be all the reasons. I think I verbalized it, but I didn't like write it down. Okay, so coming over here, this will be the first statement. You start with what you're given, and you can stop once you get to what you're trying to prove. So this will be the last statement. And on the side, you're going to put the reasons, the justification for every step along the way. Okay, now, that's why it says statements on the top and reasons on the top, okay? Because eventually you're going to do this with geometry, like prove these two triangles are congruent. What did they give you? What do you know? Why can you go from this step to the next? So you need reasons. So the very first thing you write down is what they gave you, okay? They gave me this equation. Remember, I'm trying to get t by itself. And if you never were very good at that, what you do is you try to get everything away from the t and put it on the other side. So you need to move the 5 and the 20 away. So order of operations states that when you're going backwards, you do the opposite of, please excuse my dear Aunt Sally. So you would actually subtract 5 from both sides. So I didn't write it here. I'm trying to show you a shorter way of doing it. Like if you did it in your head, it's like, okay, I would take away 5 here. So I have 20t left. And then over here, I would have d minus 5. And that's the subtraction property of equality. This is a shorthand way of writing property of equality. Okay, and then in the third step, oh, I forgot to ask. Okay, so like I'm trying to get t by itself. What would I do? I would divide both sides by 20 because I'm trying to get the t isolated. When you divide by 20, you have t by itself, and you just have this new equation, this expression, d minus 5 over 20, using the division property of equality. And what they did here, okay, so basically they're done. They showed that this equation and this equation are the same. They rewrote it to make it exactly with t on the left and d minus 5 over 20 on the right. And that's one of those properties that you don't have to use yet. And actually, if I recall, we never use it in any of the proofs that I ask you to do this year. But it's there, so I figured I'd show you. The symmetric properties states that if A equals B, that you could rewrite it as B equals A. Cool. All right. No, that's all I'm going to show you for that. Oh, no, I did leave this in here for a reason. Okay, so here's another one like this where, like I said, I'm going to more have you solving equations and putting justifications. But this is another one where they're like, if this is the formula for the area of a trapezoid, A equals 1/2. It is. That's what the area of a trapezoid is. And then the height of the trapezoid could be given by this. So somebody rearranged it. They solved for h. So if you're given this equation and trying to prove that, you would have to do algebra steps in between using those properties to rearrange it. You would have to be moving things away from the h. Okay, so you start with the given, that would be the first statement, and you stop once you get this. So this will be the last statement. So this is called a fill in the blank proof. That's why I left this in here. Okay, they did everything except for one step, and they want to know what would go right here. That could get, okay, notice what the first statement was. It was given, that's the equation. The last statement is what you're trying to get, because that's when you stop. So what did they do to get from here to here? And it says that they used the multiplication property. So if you notice, you're trying to get h by itself, and you have a b1 plus b2 here, that needs to be divided out, and that's a division property. They did that in between these two steps. Excuse me. So now they're going to multiply both sides by 2. Oh, I said it. Because I'll just show you. If you would multiply this by 2 and multiply this by 2, then these would cancel, and you would have b1 plus b2 times h left. And on this side, you would have 2a. And that way I'm using, because they give you when they do fill in the blank proofs, they give you clues on what they did, because you have to always have a reason to go from one step to the next. So the clue was, well, they multiplied something on both sides. Okay, they multiplied both sides by 2. You don't even have to say what you multiplied. So this is the statement that should go in step 2. And it works because look, it said, so then from here to here, they divided on both sides. And it's true, if you would divide both sides by b1 plus b2, check this out. If I wrote b1 plus b2 here, then these would cancel, and I would have h by itself. And if I would write b1 plus b2 here, then I would end up having 2a over B1 plus B2 like they do. So it worked, you know. Like I said, the problems I'm going to give you aren't probably going to be like that. It'll be more like solving algebra. So I want to show you this example. One last example. That's it for my PowerPoint. And that is, see, I had the book open, but I don't need to show you that. I already gave you examples from the book, so I don't need to waste your time with that. Here I have the table with the properties in it again. And this says, justify each step when solving an equation. And if it says, prove that -5 parentheses x plus 4 equals 70, prove that if this is true, then x equals negative 18. I wanted to talk about that because it's giving you an if-then statement, and you've just recently done assignments where you were working with conditionals. If a hypothesis, then a conclusion. Okay, so if, and in some of them you had to like identify the hypothesis, and it sure would have been nice if you could have just like underlined it. So this is the hypothesis right here. -5 parentheses x plus 4 equals 70. And the hypothesis is the thing that's given. And if it's written as an if-then statement, if the hypothesis, then prove this. Okay, so if that's what they're asking you here. So if this is true, then I want this to be true. So that this is the conclusion. Write a justification to prove that that whole thing is a true statement. That's a true conditional. Okay, so what you would be doing here is you would be, what would I do first? Well, I would distribute, right? So you would have, let me see if I can use text tool instead, because you would end up with -5. If you multiply -5 times x, you get -5x. -5 times +4, you get -20, -20. Okay, and then bring down the equals 70. Okay, and move this a little bit over here. So that's my first step. Actually, I forgot to do one thing. What I should have done first is to say that I need to write the whole thing. Could I copy and paste it? Let me. Yes, okay, good. So Control C, Control V. The word if there. So to do a 2-column proof, I'm going to do it as a 2-column proof. I decided. Okay, if I move this whole thing, oh, it doesn't all move. Okay. So I can just draw those again. Eraser. All right. But I do want to move my words here. Okay, so if this is my 2-column proof, and my fonts are going to be all different sizes, but this is the divider, and then at the top I have statements and reasons. So, goodness, again, a little bit more room. Okay, so this guy. Here we go. Really nice. Okay, so my very first statement there, -5 parentheses x plus 4 equals 70. Why do I know that that's true? I know that's true because it was given. All right. Then my second statement, what did I do? Well, I used the distributive property. Sure, it isn't pretty, but it'll do the job. Okay. That's how I got to that step, because I multiplied -5 times x, -5 times 4. Okay, now what would I do? I'm going to add 20 to both sides. So I could like write it plus 20 on both sides, especially if you're in the algebra classroom, you would write it. It's okay to write it if you want. What would that give me? After I add 20 here, I'm going to be left with negative 5x. And what do I have on the other side if I add 20? I have 90. Okay. Why was I able to do that? Because I used the addition property of equality. Okay, and I'm going to go back and just erase that little step. Oh, no. You knew I was going to do that, didn't you? You know what? Maybe I'll just leave that little line there. Sorry, those of you that, okay, there we go. Whew. Okay, so I'm doing a 2-column proof. I forgot to put the title. Hello, this is a statement. And these are reasons. All right, I have one last step. I'm going to divide both sides by negative 5. And when I divide the left side by negative 5, I get x. When I divide the right side, 90 divided by negative 5, check me if you don't believe it, you get negative 18. Why was I able to do that? Because I used the division property of equality. And I'm done. Because look, at the very beginning it said, prove that if this equation is true, then x has to equal negative 18. That's kind of like how you would say that. Write a justification for each step. I did it as a 2-column proof because I wanted to show you that. And yeah, so there's an example. I have one other example of something I want to show you. And it is like how Alex, oops, I need to make it into a mouse again. How Alex asks you this question. It does this. It says, the equation 7 parentheses y plus 6 equals 28 is solved. So they solved it for you. In other words, we believe that you know how to do algebra. We believe you know how to solve equations. So it's not just, the assignment's not just to solve, it's to justify each step. And they even wrote the word given equation. The word given would work. And it'll be drop-down menus, okay? And so from here to here, you could guess that you would choose distributive property, right? And then they subtracted the 42 from both sides. So it's probably going to be the subtraction property. Sometimes they call it addition property because you're adding negatives. Anywho, scrolling down here, this is how Alex describes it. This is where I got that table. I thought it was a little bit simpler than the one that the book gave us. And this is what your answer would look like. It's drop-down menus. And one of the things in the drop-down menu is simplify, because here they showed subtracting from both sides, subtraction property of equality, and then they did simplifying because they actually just subtracted it. Then they showed the division property and they showed simplifying. Okay, and your bonus for watching the whole video, remember I did that last time? A teacher last year that retired, Mr. Cuellar, every now and then he'll randomly text me. And he asked me, what kind of tree on November 12th, on my way to work, I get this message, what kind of tree could a math teacher climb? So I sent him this answer. So if you put this on your paper, then I'll give you bonus points for watching all the way to the end.